Hi, my name is Maxime Visa. I'm an undergraduate researcher at Northwestern University in Dr. Daniel Horton's Climate Change Research Group, and today I'm presenting the air quality benefits and trade-offs from vehicle electrification in the U.S. Midwest. The motivation for this experiment stems from the fact that EVs are a potential solution for climate change and air quality challenges, and the fact that few studies have modeled vehicle electrification at as high of a resolution as we do here using CTMs. The questions we seek to answer here are: one, how does electrification impact air quality? Where do we see the changes in the air quality pollutants? Specifically, we're looking at PM2.5, ozone, and NO2 here. And then, do all communities benefit equitably from vehicle electrification? The methods we use here involve using an energy dispatch algorithm to dispatch the electricity generation need from vehicle electrification to electricity generating units, or EGUs, across the United States. And then similarly, the other part of vehicle electrification involves the downscaling of on-road emissions associated with the tailpipe emissions that EVs do not have compared to their internal combustion engine counterparts. As we see in the bottom left here, we see the increase in energy demand at EGUs over the entire United States, which is the domain we use for the entire algorithm. We then later mask the rest of the US with the exception of our modeling domain, which we see here in the main figure of the poster. But what we see here is EGUs sorted by size and color, where color indicates the fuel type, the primary fuel type that the EGUs uses. And then relative size indicates the amount of electricity that EGUs are asked to supply in response to a 30% electrification rate of all vehicles. Moving on, we see that after emissions data is processed and run through our CTM, here we use WRF-CMAQ, which stands for Weather Research Forecast and the Community Multiscale Air Quality Modeling Systems. Both those two are two-way coupled to create meteorologically informed air quality and emissions data. We see here the baseline in the left column for the three pollutants, and then the difference plots in the right column. I should note that these plots here are annualized, meaning that they're averages of the 4 modeling seasons that we run. We run WRF-CMAQ for the 4 modeling seasons for 2018 and 2019, corresponding to summer, spring, fall, and winter. For NO2 and PM2.5 here, the first and third on the difference plots, what we see is a decrease in pollutants along the major metropolitan hubs, namely Chicago, residing in Cook County, and the major interstates connecting these urban areas and centers. Conversely, with ozone, we actually see increases in ozone, which is detrimental to air quality, opposed to the decreases or reductions in NO2 and PM2.5, which are a net benefit. And again, we see those major increases for ozone being co-located with urban hubs and the interstates, namely where NO2 is decreasing because of the interactions between NO2 and ozone and those secondary pollutants in the atmosphere. Looking at ozone exceedance days and the regulatory aspects of what it means for ozone to increase, we see in Cook County up to 6 additional days of ozone non-attainment per WHO's guideline of 50 ppb. And that's in several pixels over Cook County, as we see here where the dark red is, although not everywhere. Regarding public health impacts, we find 1,083 deaths avoided for NO2 and 172 for PM2.5. These are mapped on the census tract level, so the resolution is not as fine as our 1.3 kilometers squared, which we run through SMOKE, which is the emissions processing system in WRF-CMAQ. And then for ozone, the census tract level, we find added deaths of 82, and these are on a yearly basis, so per year as a function of our 30% electrification. Overall, we find that downtown Chicago is subject to the greatest change in pollutant concentrations. Areas of NO2 decrease show increases in surface level ozone, they're inverse. And NO2 and PM2.5 reductions benefit public health, while changes in ozone do not. Thank you.